Okay, here's another example. Here are the facts. Cylinder, yes. 2x, cone, radius, height, yes. So it's just as it's drawn. The volume of the cylinder and the volume of the cone are equal. Find h in terms of x. Okay, so we need to know the formula for the volume of the cylinder, and we need to know the formula for the volume of the cone. This is like a cake of DVDs. It is the base area multiplied by the height. So volume of the cylinder equals the base area, which is pi r squared, multiplied by the height. And the volume of the cone, this is another formula you should probably know. It comes up an awful lot. It's a third pi, well, there's a circle involved, r squared h. Notice while we're here, we have 3 dimensions. 2 dimensions trapped in the r squareds, and the third dimension in the form of h. All volumes must have 3 dimensions multiplied together. Areas have 2, lines have 1. It's a good sort of check that if you've forgotten the formula, it must have those 3 dimensions if it's a volume. Okay, all we've got to do is plug in our values. Let's do the cylinder first. We get pi. R squared, well, in our cylinder terms, it's x squared. H is 2x, and that must be equal to a third pi. The r, again, is an x, so this is x squared, and the height is h. It's worth having a look what we need to find. We need to find h in terms of x. Okay, so we need h on its own. But before that, we can do some cancelling. That goes with that, and the pi goes with the other pi on the other side. What are we left with? Well, we've got 2x on this side, and we've got a third h on the right-hand side. They want h on its own. First of all, I'll swap that around. So I get a third h is equal to 2x, multiply across by the 3, and we get, therefore, h is equal to 6x. And that is your answer.